Well, thank you, Jason, for the invitation. Jean kind of gave a lead in to our agency, so I'm not going to be redundant. We have similar stakeholder interactions, so I'll just jump into what the Hydraulic Engineering Research Unit in Stillwater is. We're actually not the only unit in Stillwater. We have the Wheat, Peanut, Other Field Crop Sciences unit focused on pest management of some of our commodity crops here in the state. But what I'm going to focus on is our Hydraulic Engineering Research Unit, which has a mission to develop criteria for the analysis and design of conservation structures and channels and conveyance, storage and measurement of runoff waters. Okay, we have been in Stillwater since 1940, located just downstream of Lake Carl Blackwell, and that's a significant location because we can draw 120 cubic feet per second of gravity flow directly from the lake that is delivered through a network of channels, or we can tap in through pipes and provide flow into indoor model facilities. So we do physical modeling at a very small scale up to prototype scale if we need to. We have 100 acres downstream that allow us to do that large scale testing. Historically, we were set up to develop design criteria and standardization for grassline channels. That was so successful, we were recognized as a historic landmark in 1990 for that work. So next time you fly out of Will Rogers, take a look across the landscape, you're going to see the impact of our work. Over 500,000 miles of grassline channels around the world. Because of our work, we've developed flow measuring calibration techniques and engineering tools, such as the jet erodibility device, as well as those H-flumes you saw previously. We get involved in grade stabilization structures, standardizing the design criteria for those. Several examples, you can see the physical model versus what's out in the field, as well as other grade stabilizations like rock chutes, as well as in-stream rock chute development. But the main focus of our research today has been to support the USDA Small Watershed Program that's been responsible for constructing 12,000 flood control dams across the nation. Here in Oklahoma, we lead the nation with over 2,100 of those. So if you hear Oklahoma has the most shoreline, this is why, okay? Where do we come in? They wanted to standardize the design of these upstream reservoirs or upstream dams on the upper tributaries in these so every aspect of the dam has a standardized design. Whether you're in Oklahoma, California, or New York, you're going to see the same design. So we had a hand in the inlet, the outlet, the auxiliary structural spillways, as well as the auxiliary vegetated earthen spillways. We've also developed software to predict erosion and spillways, and again, this work has been recognized as a historic landmark. Today, we're focused more on these aging infrastructures, so looking at overtopping protection systems. We have large facilities, as I mentioned, where we can do full-scale testing, and then looking at if we can't protect them, what's the consequence? What may happen to these dams? And that's where we can do embankment overtopping, internal erosion tests, and examine the erosion processes that may occur. We're not only using this in USDA, but the Corps of Engineers is using the relationships that we're developing and using in our prediction models for predicting embankment failure. What's the impact? The impact of our work has resulted in a $2 billion annual benefit that these structures provide, not only flood control, but recreation, wildlife habitat, rural and municipal water supplies. So with that, that gives you a brief overview.